So I've gone ahead and I've started factoring this problem. We're asked to factor completely using trial and error, 18x squared minus 3xy minus 10y squared. So we have to look at all of the factors of the first term and all of the factors of the last term. So we're looking at x and 18x, 2x and 9x, 3x and 6x. Since it's minus a minus, we know it's going to be a combination of one being positive and one being negative. That's the only way we're going to multiply to a negative number and add to a negative number. So this is going to be y and negative 10y, 2y and negative 5y, negative y and 10y, or negative 2y and 5y. And now we have to look at all possible combinations of our first terms and last term factors. So first we'll look at 18x, so x and 18x, so x, we'll go with first and first, so x plus y times 18x minus 10y. Well, we already know that that's a no, because since this has no greatest common factor, 18, 3, and 10 have no greatest common factor, plus there's no y term in the first term, there's no y variable in the first term, there's no x variable in the last term, so there are no greatest common factors, so we know that the binomial that it factors into will have no greatest common factor, so that's not going to work. So now we'll swap those, and I forgot to put my y here. I said it, but I didn't write it. So 18x minus 10y. So now we'll swap those, x minus 10y times 18x plus y. There's no common factors with that. So we know that it might work. So 18x squared plus xy minus 180xy, that's minus 179xy. So we automatically know that this is a no. We don't even need to multiply the last term. We know it's going to be minus 10y squared anyways. So now I'll go on to the next one. So we have x plus 2y times 18x minus 5y. That's going to equal 18x squared, and then minus 10y and plus 36y. And again, that's from the minus 5xy plus 36xy. So that's going to be plus 31xy. So that's not what we want. So we'll swap the last terms now. So x minus 5y times 18x plus 2y. That equals 18x squared minus 10y, or plus 2xy, excuse me, plus 2xy minus 90. 5 times 10 is 50, 5 times 8 is 40, so that makes 90. So 2xy minus 90xy is minus 88xy, so we know that's not it. So now we go on to the next one. X minus y. So we're on this row right here, our third row. X minus y times 18x plus 10y. And I should have noticed right off the bat this was a no. I got ahead of myself because 18 and 2 have a common factor. Now 18 and 10 have a common factor, so we know this isn't it. And then last but not least, we switch that around. X plus 10y times 18x minus y. We switched around the 10y and the minus y. No common factors, greatest common factor in either of the binomials, so this is 18x squared minus xy plus 180, so that's plus 179 xy. So we know that's not it. And again, we're not doing the last term because we know it's going to be minus 10y squared. If the middle term's not right, we don't need to multiply that through. So then x we're on to the fourth row for the factors of the last term. So x minus 2y times 18x plus 5y. That equals 18x squared plus 5xy minus 36xy. So that's going to be minus 31xy. So we know that's not it. Now we go on to, we've gone through all four rows for our first set of our first factor. So now we're going to go on to 2x and 9x. So 2x, and we're going back up to the top row up here, y minus 10y. So 2x plus y times 9x minus 10y. No common factors. So 18x squared, and then 2 times negative 10 is negative 20. So negative 20xy plus 9xy is minus 11xy. So we don't need to go on with that one. So we'll switch the second terms around. 2x minus 10y times 9x plus y. We have a common factor of 2 with 2 and 10, so we know that one's a no. So we'll go on to our second row. 2x plus 2y times 9x minus 5y. We know that's going to be a no because we have 2x and 2y. That has a common factor of 2. So we know that one's a no. We'll switch the second ones around. So 2x minus 5y times 9x plus 2y. No common factors, so that gives us 18x squared. We have plus 4xy minus 45xy, so that's going to be minus 41xy. So we know that's a no. So now we go on to our next row, which is going to be 2x minus y times 9x plus 10y. That equals 18x squared. And then plus 20xy minus 9xy. That's going to be plus 11xy. We don't need to go on to the last terms because we know that's not it. So we'll come up here and then we'll switch those around. That's going to be 2x plus 10y times 9x minus y. Well, we already know this is going to be a no because we have the 2 and 10 as coefficients. So now we'll go on to the fourth row again. For our factors of our last term, we end up with 2x minus 2y. We already know that's going to be a no. And then 9x plus 5y. We know that's a no because we have the 2 and the 2. So we'll switch those around, the 2y and the 5y, so we end up with 2x plus 5y times 9x minus 2y. That gives us 18x squared minus 4xy plus 45xy plus 41xy, so we know that's a no. And so we'll go on to our third row for our leading term. So 3x, and then we'll go back to our first row for our last term as well. So 3x plus y times 6x minus 10y. Well, we know that's a no because of the 6 and 10. They have a common factor of 2. So then we'll switch the y and the minus 10y. So 3x minus 10y times 6x plus y. No common factors there, so we can multiply it out. 18x squared, and that's going to be plus 3xy minus 60xy. So that's going to be minus 57xy, so we know that's not it. So we'll switch to the next row. 3x plus 2y times 6x minus 5y. No common factors, so we can multiply through. 18x squared minus 15x plus 12x is going to be minus 3xy. So after all of this, we finally found, we take 2 times negative 5, that's going to be minus 10y squared. We finally found our factors, and it's going to end up being 3x plus 2y times 6x minus 5y. And the one benefit of trial and error is that you don't need to check, because that's essentially what we're doing when we multiply to check to see if it's the correct factorization. So 18x squared minus 3xy minus 10y squared, we looked at the factors of the leading term, the factors of the trailing term, the last term. And then trial and error, we looked at every possible combination until we got to the right combination to give us the factorization that when we multiply through, we end up with the original expression that we were given.